So yeah, so we're going to solve equations using perfect square and difference of squares. And we already know these patterns here. So this was your difference of squares, which you've been doing a lot. A squared minus b squared, a plus b, a minus b. And that's an example how you factorize. Then the perfect square trinomials, tri being 3. So we have 3 terms here. And we have these already. We've used these before. So a squared plus 2ab plus b squared is a plus b all squared. And when it's negative, then we'll have a minus b all squared, okay? And we've done these already a lot, so you're probably used to them. So we're going to be using these ideas to solve equations that can't be solved with factoring, okay? Because a lot of questions can't be factorized. So for example, x squared plus x plus 1. You can't write that as 2 factors, okay? This would not be possible, okay? So we can't write this using x and some number. So many times you'll get equations that can't be solved by factoring. And so we need some other methods. Okay, so the important idea here is this completing the square idea. And we'll use a diagram to show that. So what it means is that completing the square means to add a term to a quadratic expression that will enable it to be written as a perfect square. So in this example, which I'll make a bit bigger, like that. So take a look here. So we've got x squared plus 10x. Okay, so what we should be thinking about is our perfect square rule. So we would have a squared plus 2ab plus b squared, which is a plus b all squared. So if you look here, we've got a, which is going to be x, okay, which is here. Then b must be 5. So we need a number here that will equal 10. So this would be a squared. Well, let's write x squared actually. So let's use the actual number. So we'd have x squared plus 2 times x times 5, because this number is already 10. Okay, and 2 times 5 is 10. So this would have to be 5. And the last number is 5 squared, isn't it? Like that. And so that would be x plus 5 all squared. So this number up here was actually 25, which is 5 squared. You see that? So 25 is 5 squared. I'll leave this here for a while so you can copy it on your sheet. If you didn't print the file or don't have a tablet, you can just write down on a notebook. And so that means this number here is 5. So we'll write that in there. Now I did this diagram so we could think about what this looks like. Now these are squares. Complete the square. Okay, make it full. So what you actually have here, we have an x squared. So I'll write x squared there in this box. Now this is 10x. So what we do with 10x, we split that to 5x, 5x. So I'll write 5x here, equally divided by 2, 5x. So 5x, 5x is 10x when you add them. And this number is 25 in here. Your factors, which are x plus 5 times x plus 5, would go here, x plus 5, x plus 5. So x plus 5 all squared would be the sum of these 4 areas. Remember, we're thinking about area now, not just numbers, so area. So x squared plus 5x plus 5x plus 25, or 5 squared if you like. So that would be x squared plus 10x plus 25. Okay, so I'll leave that there for a little bit. Why don't you think about the next one then? Okay, how about this one? So I'll write the formula below here and I'll give you a few minutes to see if you can fill this one in yourself. Okay, so a squared. Now we have a minus, so minus 2ab plus b squared equals a minus b all squared. So I'll give you a few minutes, see if you can do this black part here. So for this question, you've got x squared minus 2, a is x, b must be 4, you see, because 2 4s are 8. So this number must be 4 plus b squared, which is 4 squared, which is a minus b all squared. So x minus 4 all squared. Okay. And so this is equal to minus 8x, which is necessary. By doing that, that's how we get the 4, which goes in here. So if you're filling in your diagram, we would have x squared in here. Now the minus 8 needs to be split to be minus 4x, minus 4x. They have to be added to be minus 8x here. And then your last number is 4 squared, or 16 if you like. Let's write 4 squared equals 16, like that. So then we would write our factors. So this would be x plus negative 4. So instead of writing minus here, I just add negative, which is the same as x minus 4, okay? So then I've got x plus negative 4 here. So if you've got any errors, you can fix it up. So then we could write our perfect square as x minus 4 squared is x squared minus 4x minus 4x plus 16. Then add your two middle terms just to check everything is okay. Plus 16. Okay, that's x minus 4 squared. So that's your original here. So we could fill that in as 16. And this would be x minus 4, like that, okay? So you can always review the video to get the rest of the solutions. Now this one. So think about we can just go straight to the diagram, couldn't we? Right, let's just go to the diagram first, and then we'll go back to this. There's a couple of ways we can do it. So remember, the first box will be x squared. Okay, but these two are half of this number, which would be 3x on 2, okay? So these are split. So this would be 3 on 2x. Let's tidy that up. 3 on 2x, and this would be 3 on 2x. So it's 3x divided by 2 because it needs to be split equally because they're the same size. And so what number would go here then? You see this 4x, this actually, I could have written this as minus 4. I should have written that like that. Okay, minus 4 squared, which is 16 anyway. So here, this box would be 3 on 2 times 3 on 2. So 3 on 2 squared, which is 9 on 4. So then we could go and fill this side in here if we want. So the factors would be x plus 3 on 2. We don't need bracket there, but anyway, x plus 3 on 2 here. And each of these boxes represent the area. So let's think what that looks like. So we've got x squared plus 3x plus this number, 9 on 4. That would go here, which is 3 on 2 squared. Let's write that there, which is 9 on 4. So when you do work for me, just put it in this form here. You don't need to put the power 2. Just simplify to 9 on 4. Then this number was in here, which is going to be 3 on 2. Okay, which is this number here. You see, x plus 3 on 2. There. So that number is here. Okay, and that 9 on 4, this 9 on 4 is here in this box here. So that one's finished. I just did the box first. But if we want to write out our formula, we would have x squared plus 2x. This must be 3 on 2, because 2 times 3 on 2 is 3. The 2 will cancel. Plus 3 on 2 all squared, which is 9 on 4. So we could have written it out like this as well, which gives us those factors there. So that's one way to look at it. Now, imagine you had the general form x squared plus bx. This is what you're going to need to know, this here, this general form. X squared plus bx plus what will equal x plus what squared. So before you look in your textbook, do you know what maybe goes in here? Can you think about that for a minute? Think about what you would write here. If this is b, a number, what would you write here? So let's write an example as we did before. X squared plus 10x plus 25 equals x plus 5 squared. And I'll write another one below it so you can think what it might be. So x squared plus 6x plus 9 is x plus 3 all squared. So imagine this is the b number here. And then think about what would go in here. In there. So think about that for a minute, because this here is your formula. This is the formula you'll need to remember. And you do this a lot in this section, so you'll remember it eventually. Okay, so think about that. If you think you know what it is, write it in. Compare these numbers here too. Look here. You've got 6 here, and this is 3. Okay. You've got 10 here, and this is 5. So this looks to be half, isn't it? Half of 6 is 3, half of 10 is 5, half of b is b on 2. So b on 2 goes here. So whatever this number is, 10, half of 10 is 5, half of 6 is 3. But what about the 9? So think about this 9 and 25. So how are these numbers, 3 and 5, related to 25 and 9? Do they look like to be powers, don't they? This looks to be a power. 3 squared is 9, 5 squared is 25. And this number is b on 2. So we would have to square this number. So b on 2 squared, like that. Okay, so that's the formula you're going to need to remember. So I'll write it down again here. So x squared plus bx, it could be minus as well, plus b on 2 squared. It may be negative in here, but when you square a negative, it's positive anyway. And that would be x plus b on 2 squared, like that. But it may be negative. If it's negative, you'll have a negative in here. I should write that as a different color. So if you have a negative here, this will be negative, but when you square it, it will be positive. This number will become positive anyway, and this will be negative here. Okay, so we'll see how to use this idea. So let's say, before we go to those examples, let's do a couple of questions here. So you've got two parts. You've got x squared plus 12x plus what equals what plus what all squared. So we want to make this a complete square. So we want to know what number must go here to be able to write this. So remember, in this number is, back to our formula, bx, b on 2 squared. So what you do, you would take this number 12, you will halve it and square it. So you'll get 12 on 2 is 6. 6 squared is 36. That's the number you write here. Okay, and then we've got an x here. You'll always have x or y or something like that. So x will go there. And this number is the square root of 36, or b on 2. That's b on 2 there. So 12 on 2, which is going to be x plus 6 all squared. So x squared plus 12x plus 36. There. My pen's gone crazy. Hold on. So x squared plus 12x plus 36 is, hold on, my pen has gone nuts. So x plus 6 all squared. Hold on, just reconnect my pen. Sometimes it does this, I don't know why. See if I can get it back or not. Where is my pen? Oh, there it is. No, I might buy a better pen. Okay, so let's look at how we use this to solve equations, actually. Get it to work. Okay, come back here. Okay, so we're going to use this idea to solve these problems. These are actually in your book, 170 to 173. So you can take a look there if you want. You don't have to copy these, but I may show you differently than what's in the book. But what I'll show you here is what I think you should show in your working. Okay, so let's take a look here. Okay, so pen, there. Sometimes it disappears. So you've got x squared plus 8x equals minus 7. So what we do, we look at this part here. Okay, and we try to complete the square here in this section. Ignore the minus 7, that will come in later. So you want to have x squared plus a number x. So then what we'll do, I'll write it here. So x squared plus 8x. So we take the 8, we halve it and square it, which will give you 16. Okay, this is your special number here. So let's put that in yellow and green. So then I'll write this again. I'll go x squared plus 8x plus 16. Okay, now what I've done here actually, I've added a number into my equation. Yes, you see? So I put a number in here, but you can't just do that. You have to be able to balance the equation, which means that you need to add that number to the other side. Otherwise, your equation has changed. So that's very important. So I do my complete square procedure here. Middle number, half and square, I get 16. I add that number to both sides, here and here. Okay, so then this can be written as a complete square, which is x. Now this sign is plus, so we write plus. And this number is the square root of this number. That's the quick way to do it. So if that's 16, this will become 4, all squared. So now this here is the same as this. And now you've got minus 7 plus 16. That's going to be 9, isn't it? 9. Okay, now it looks really easy to solve because you've done this already, haven't you? You did this in the previous section. So what you do now, we can make it a complete square. We'll use difference of squares. So we'll have x plus 4 all squared minus 9 equals 0. So now we make this 3 squared. Equals 0. So now I just use difference of square rule. So x plus 4 minus 3, x plus 4 plus 3 equals 0. So this will be x plus 1, x plus 7 equals 0. So therefore, x will equal minus 1 and minus 7. So this equation could have been solved by factoring. We could have done this by factoring. You see how nice the numbers are? We have nice numbers here. So actually, you could have factorized this question, which would have been a lot quicker. All right, let's try another one. I'll go up a bit slow. If you want to copy, you can, but it's in your textbook. So it's probably a better idea just to watch as we're doing it. So in this question, you've got x squared 8x. This 9, when I have a number on this side, I like to push away to the other side. So just remove any other numbers. So x squared minus 8x equals minus 9. So now we're going to complete the square with this. So I'll do it over here. X squared minus 8x. So this number you want is half of minus 8 and square it, which will give you minus 4 squared is 16 again. So that becomes plus 16. I'll put that here. So that number is this number here, which means you can write that as x minus 4 all squared. So we'll come back to here and do that. So we've got x squared minus 8x plus our special number, call that your special number, which comes from here. Add that number to your equation, but then remember to add it to the other side as well, like that. So that special number in yellow now is here and here. So add those two numbers to your equation. Then we'll make this a complete square now, because we did that already here. So the way I remember, I see an X here, so I write X. I see a minus sign, so I write minus, and I write the square root of 16, which is 4. That's the way I remember that number. It's beyond 2, but I don't bother with that. So it would be 4, okay. All squared equals 16 minus 9. That's going to be 7, isn't it? 7. Okay. So you can do this by your difference of squares like the previous one. So we can do that here. And I'll show you another way, which is actually a bit quicker. So we've got x minus 4 all squared minus 7 equals 0. Because you have 7, which is not a perfect square, we will need to make that minus root 7 squared equals 0. Because root 7 times root 7 is 7. So you'll need to do that. And then we do our difference of squares. So x minus 4 minus root 7, x minus 4 plus root 7 equals 0. This is actually a lot longer than the quick way. I'll show you the quick way in a minute. So then we'll end up with x minus 4 minus root 7 equals 0. So x will be 4 plus root 7. That's your first answer. And this one would be x minus 4 plus root 7 equals 0. So then find x. X equals 4 minus root 7. So those are your two answers. But I think this is a bit of a long way to do this problem here. So once you get to this step here, I'll show you another way to do it. Okay, I'm going to rub this out here, but that's one way you can do it. So let me rub this out and show you another way. So what I recommend at this point, I wouldn't bother about the difference of square rule. So let's do another way. So you've got x minus 4 squared equals 7. So bring your 7 back over. Now what I'll do, I'll square root both sides, here and here, because a square root will always cancel a square. But you're going to get two solutions on this side. So I should put plus or minus in here. Let's make that bigger. So plus or minus root 7. So you're going to have x minus 4 equals plus or minus root 7. So x then will be 4 plus or minus root 7, which is the same as what I just showed you with the difference of square rule. So I would do it this way. I think it's a bit quicker. The key here is you need to remember to put plus minus here, and that this square root will cancel this square to just give you x minus 4. The reason why you've got this plus or minus, imagine you have minus 3 squared, you'll get 9. 3 squared is also 9. So when you square root 9, you actually have two numbers that work, plus or minus 3. Because minus 3 squared is 9 and 3 squared is also 9. That's why you need this plus or minus sign here. So you have to forget about grade 6 work when a square root 9 is only 3. Because for quadratics, you can have two solutions, plus or minus. Okay, so that's that one done. Most of today, I'm just kind of explaining how to do these, I think. Well, I'll give you a chance. Why don't you try this one yourself? It's in the book, but why don't you try this yourself if you have a tablet? So I'll give you 5 minutes. Okay, the 8 is already on this side. So now you need to complete the square here. So I'll come back down so you can see this one here. So try 3 yourself and I'll do it in a couple of minutes. So for question 3, let's see how you're going. So when I look at that, I'll just write this here, x squared plus 4x. So half of 4 is 2. And then I square that number, I will get 4. So the special number you need to add on this side is 4. So x squared plus 4x plus 4 equals 8 plus 4. So your special number, which is 4, which comes from here, add that to both sides, like that. And then this will give a perfect square, which will be x plus the square root of that blue number, which is 4. Square root of 4 is 2, all squared. So once you do this procedure and get this special number, you can directly write this complete square here. And 8 plus 4 is 12. So you could do that by difference of squares. But what I think I'll do, I'll just square root both sides. So you'll have square root here, square root here. So you'll end up with x plus 2 equals plus or minus root 12. Okay, now root 12 can be simplified as root 4 times root 3, 3/4 of 12. You can do this with surds. These are called surds. So I'll tell you a bit about this year, so you're aware of it. A lot of this is done in grade 10. So root 4 times root 3 is root 12, and root 4 is 2, so 2 root 3. So I recommend you simplify these. Your calculator will do it anyway. So if you type root 12 and press equal, you'll get 2 root 3. So then you've got x plus, oh, let's move to 2. Oh, let's write 2 first. So plus 2 equals plus or minus 2 root 3, because that's root 12. So x equals minus 2 plus or minus 2 root 3. So that's your answer. If you write it as a decimal, you'll get 1.46 and minus 5.46. So this would have been very difficult to factorize this question. You could have done it, but you have to involve roots like this. So, and it's just not practical to do that. Factorizing is okay if the factors are like fraction or whole number, but not when you're involving these irrational numbers, these root numbers. Okay, so that's the answer for that one. You can leave in both form if you want, but that's surd form. So this would be written as surd form or exact form. And this is rounded off. That's as a decimal. Decimal. And I recommend 2 decimal places if you write as a decimal. I may want it as decimal, but if I do, 2 decimal places here. That's enough. Maybe 3, but some students like to write 10 decimal places. I'm not sure why. Okay. All right, let's look at maybe one more. Are they getting harder yet or not? Now this one, I'll talk a bit about this. We'll go over more of these next week. Now you've got 3. You don't have x squared, so you've got a problem. I need this to be x squared something. Okay, I can't have a 3 here. So like we did before, you could divide everything by 3. So I recommend to do that. 3, 3, 3, 3. Okay, so divide everything by 3. So now we'll be gone with this 3 here. Just make it a bit bigger because this one's a little bit harder. Making it bigger will make it easier, but anyway. So x squared minus 4 on 3 x minus 2 equals 0. Okay, so this lonely number on the end here, just push him away. He's got no friends, so kick him away over there. Don't need it. So then we will complete the square in this part here. So let's write that down. X squared minus 4 on 3x equals 2. Okay, so this is the bit you need to complete square here. I'll do that over on this side here. So we want a number here that will help us complete the square. So as we said before, you halve this number and then you square that. You can do it in your calculator if you want, up to you. But if you do these by hand, minus 4 on 3 divided by 2 is actually minus 4 on 6. So the long way would be minus 4 on 3 divided by 2, which is minus 4 on 3 times a half. Remember, when you change to multiply, this fraction will flip over. So 2 will become a half, and that becomes multiply. So this will become minus 4 on 6 squared. And 4 on 6 is 2 on 3. So I simplify that. Looks hard, but stick in your calculator. It's much easier. And that would become 4 on 9. 4 on 9 is our special number. All that work, but as I said, you can put this in your calculator. All right. But the quick way, you just multiply 2 and 3. That would become 6. So 2 times 3 is 6, and do it that way. So our special number is 4 on 9. So x squared minus 4 on 3x plus 4 on 9 equals 2 plus 4 on 9. Let's just check I did that right. Yeah. So complete square will come from this green part here. This method does take some practice. So if you're going to copy someone's work, it might be a problem later on. You really have to try to understand this by yourself. So this here can be written as a perfect square. We have x, so we have x. We have minus, so we have minus. The square root of 4 on 9 will be 2 on 3, all squared. So that number here is always the square root of this number. That's the way that I do it. And 2 plus 4 on 9, if you don't have a calculator and a Thai exam, if some of you are going to Thai schools next year, a lot maybe, you need to do this without a calculator. So 2 plus 4 on 9, I would write that as 18 on 9, which is 2, isn't it? Plus 4 on 9. So now I have a common denominator. So x minus 2 on 3 squared equals 22 on 9. And then I will just use my method from before. Again, without a calculator, you will use calculator to help, that's all right. But show the steps anyway. So square root both sides, like that. So the procedure, you still need to know the procedure though. Cancel the square, you'll have plus or minus here. So you'll end up with x minus 2 on 3 equals plus or minus the square root of that. I know some of you probably reached to the calculator now, but we can still simplify this a bit. I'll show you. So x minus 2 on 3 equals plus or minus. Now, square root 22 on 9 is the same as square root 22 on square root 9. This root can be split to two parts, top and bottom. Okay, so you're going to get x minus 2 on 3 equals plus or minus root 22 on 3, because root 9 is 3. Looks hard, doesn't it? But as I said, you'll have calculator to help. X minus, well, let's bring the 2 on 3 over. So the minus 2 on 3 would become 2 on 3 plus or minus root 22 on 3. So now you see we can combine that, can't we? So 2 plus or minus root 22 on 3. And you can leave that as the answer, or you can make a decimal. As a decimal, I got 2.23 and minus 0.90, 0.90, that there. So that is one way you can do that. But like I said, you will have calculator to help in here. You can do this with your calculator if you like. That's the best way, I think. I might stop there. We'll go on to this one. I better mark it. So for the next class, I know we got to this number here.